When we talk about the speed of light, we're usually just referring to how fast light travels through space, about 300,000 kilometers per second in a vacuum. But here's the thing, this speed, this constant, is so much more than just the speed of light. In fact, is deeply intertwined with the fabric of reality itself. It governs not just light, but how the universe communicates, how forces propagate, and even how time and space behave. Let me explain how this works because it's not just fascinating, it's mind-bending. We call the speed of light because it's how fast light travels in a vacuum. But the reason for that speed isn't arbitrary. It comes straight from Maxwell's equations. 4 fundamental equations that describe how electric and magnetic fields behave. These equations predict that changing electric and magnetic fields propagate through space as waves, and the speed of those waves is determined by the vacuum's electric permittivity and magnetic permeability. And when you calculate that speed, you get. So, in essence, the speed of light isn't just about light, it's the result of the properties of the vacuum itself. The very nature of empty space sets this speed. Whether you're talking about visible light, radio waves, X-rays, or any other form of electromagnetic radiation, all of these waves travel at because they are governed by the same underlying rules. But here's where things get even stranger. It turns out that is also the speed of something much more fundamental. In our universe, no information can travel faster than. Whether it's light, radio signals, gravitational waves, or any form of causality itself, the fastest anything can move from one place to another is. This is why the speed of gravitational waves, the ripples in space-time caused by catastrophic events like colliding black holes, is also. Einstein's general theory of relativity tells us that massive objects curve space-time, and when these objects move or interact, those changes ripple outward. But those ripples don't just spread out at some random speed, they travel at exactly. So, whether it's light or gravity, isn't just a number that describes how fast something happens to be moving. It's a universal constant that tells us how fast can happen. This speed limit isn't something imposed from the outside, it's a fundamental feature of space-time itself. If you tried to go faster then, you wouldn't just be breaking a law of physics. You'd be trying to break the very structure of reality. Now let's get into why this matters so much. Imagine a world where information could travel faster than. What would happen if you could send a signal instantaneously to another part of the universe, or if gravity could act faster than? The answer is paradoxes, lots of them. Imagine a star that suddenly collapsed into a black hole. If gravity could travel faster than light, the planets orbiting that star would immediately feel the change, before any light or other signal could reach them. This would violate causality, effects would happen their causes. Essentially, the universe would stop making sense. In special relativity, time and space are intertwined. If you allow something to go faster then, you get into situations where different observers would disagree on the sequence of events. One might say that something happened an event, while another could say it happened. Without as a universal speed limit, the concepts of before and after become meaningless. The logical progression of cause and effect would dissolve. And that's not just a small inconvenience, it would destroy the consistency of our entire physical reality. Electromagnetism, gravity, and the universal binding agent. So why do electromagnetism and gravity, two seemingly unrelated forces, both obey the same speed limit? It's because they are both mediated by massless particles, photons in the case of electromagnetic waves, and theoretically gravitons in the case of gravity. The fact that these particles are massless is crucial. According to relativity, anything that has mass requires more and more energy to move faster. As you approach, the energy required to go even slightly faster becomes infinite. Massless particles, on the other hand, are required to move at. It's their natural speed. Light, in the form of photons, travels at because it has no mass. Gravitational waves, which are ripples in space-time, travel at because they are also carried by a massless entity. The gravitational field itself, in fact, is baked into the very fabric of general relativity. It shows up in the equations that describe how space-time bends, how gravity works, and how objects move through this warped space-time. Without, gravity wouldn't just stop functioning in the way we understand it, it wouldn't function at all. Special relativity, why defines time and space? Let's go deeper into special relativity. According to Einstein, the speed of light is the same for all observers no matter how fast they are moving. This might seem simple at first, but the implications are astonishing. It means that space and time have to stretch and compress to ensure that everyone measures the speed of light to be the same. If you're moving close to the speed of light, time for you slows down relative to someone who is standing still. Distances contract, and as you approach, these effects become more extreme. If you could actually travel the speed of light, time would stop altogether, and the universe would be flattened in the direction of travel. From light's perspective, the journey from one end of the universe to the other is instantaneous. For any object with mass, though, it's impossible to reach this speed. As you approach, the energy required to continue accelerating increases without bound. That energy becomes infinite, meaning that nothing with mass can ever get there. Only massless entities like photons can exist at this cosmic speed. And the structure of the universe. What's really mind-boggling is how this one constant is tied to almost everything fundamental in physics. It tells us how fast light travels, how fast gravity propagates, how time and space behave, and how energy and mass are related, through the famous equation. Even quantum mechanics, which might seem like a completely different realm, is not immune to the influence of. The equations that govern the behavior of subatomic particles incorporate to ensure that they respect the relativistic structure of spacetime. Ultimately, is not just a number that happens to describe the speed of light. It's a fundamental constant that tells us how the universe works at the most basic level. Without, there would be no coherence in time or space, no order to events, and no way for the universe to function as we know it. In conclusion, the ultimate constant. So the next time someone tells you that the speed of light is just how fast light travels, remember, it's so much more than that. Defines how the universe operates, how time flows, how space stretches, and how cause and effect remain consistent across vast distances. It is the speed of light, yes, but it's also the speed of gravity, the speed of electromagnetism, and the speed of reality itself. Without, the universe would unravel. With, everything stays in balance. It's the cosmic glue that holds space-time together and makes the universe comprehensible. And that is truly mind-blowing.